Hello and welcome to week 4 of the MMO development class. I'm going to be here and my name is Nelson. So what we're going to do today is we're going to kick off where we left off last week and actually get some stuff going. My goal for today is to see about actually getting the lobby working in a better way than we did before. See, previously when we had the chat thing, you couldn't see like the names of the people who were chatting or anything like that, and the system didn't have any sort of way to monitor who was in the lobby and who wasn't in the lobby and blah blah blah. Multiple people could log into the same account, which we also want to prevent. So we're going to be playing around first off with some server-side code to get a sort of basic model for our lobby up and running, and then once we get that working, we'll jump into the client and see about getting Photon events working properly. So with that, I'm going to go ahead and fire up my solution. So right now what we have here is we have our login and our register. And our login and our register both have a response that passes in the user information back to the client, but we're not actually stuffing them into a lobby quite yet. So we need the concept of a lobby somehow. Now the way to do that would typically be Visual Studio isn't showing. Well, okay, I'm going to go ahead and pause the video and wait for the webinar system to catch up here. And we're back. Sorry about that. The webinar decided to make Visual Studio hidden until I started it and started it back, or stopped it and started it back up. So I was saying words. What words were I saying? I was saying something about how we have this object, this application object, which kind of represents the context of the entire application and is typically where you would place things that are, well, application-wide, such as who's logged in, where are they in the lobby, are they in a game, what are they doing? So I have this idea for handling data for peers and applications, and it's very similar to the way Unity itself works with components. And what I'm going to do is I'm going to use a registry pattern and a component pattern to, well, do stuff for that. And what I mean about that is what I want to be able to do is I want to be able to attach data to the application class. And I also want to be able to attach data to the peer class. And I want to be able to do that without in a way that's well designed and doesn't step over each other's toes. So I want to be able to tell the Rune peer that it's logged in, but I don't want to actually have to modify the Rune peer class in order to do that. So I'm going to be using the registry pattern where I'm going to register facets to my peer and to my application. And then I'll be able to use those facets in order to attach more data to them or functionality. So the idea is that I'll have a lobby facet associated with my application. The lobby facet is going to be responsible for owning a collection of all the different peers that are attached to it. And then for the peers, I want them to have an authentication facet, or sorry, an authorization facet, which I'm probably just going to shorten to auth facet, which denotes that a peer is indeed authenticated and will give whoever tries to access that facet information about that peer's, well, authentication. So let's get started. I'm going to go ahead and write a registry class. Now the registry class is going to be responsible for containing a collection of facets. So let's go ahead and figure out how we want to write this. We probably need a private read-only dictionary of type and object, sure, why not? And then we'll call this actually, you know what? To keep this sort of in line with the terminology used in Unity, I'm no longer going to use the word facet, I'm going to use the word component, because that keeps it in line with the way that Unity itself deals with this sort of pattern. And we want a few different accessors. Now, the problem about all sorts of problem about this sort of code is that we're potentially going to be accessing facets from multiple threads. So we're going to be able to need to handle the way in which threads are allowed to access our components, because we don't want to run into a situation where we have a race condition because two things are trying to access the same component at the same time. Now, some components will be able to be thread safe, while other components cannot be thread safe. For example, a lobby component is, it's pretty much not thread safe for the majority of the types of operations that are going to be performed on it. Same thing with the game component. Now, I'm going to be very pessimistic about my locking. And the reason I'm going to be doing that is to simplify the code in the context of this application. However, if you were building a game, a more real-time game such as an MMO, you would want to be more optimistic about your locking to prevent, to increase the performance and throughput of your server. But for right now, I'm going to be very pessimistic about that. And what I mean by that is I'm going to have, first of all, I'm going to have a set method. The set method will simply say components at type of tComponent equals component. So hopefully that code should be pretty straightforward. That's our set method. But now we need a get method. We need to be able to retrieve a component out of the registry. And in the interest of making this pessimistically locked, what I'm going to do is I'm going to write the method like this. Get tComponent. But what it's going to take in, it's going to take in an action of tComponent called action. Now what I'm going to do is I'm going to create a private read-only dictionary of type and object again, and I'm going to call this component locks. And this is going to be a dictionary that contains the synchronization objects for each one of our components. Every time we set a component, I want to set this to a new object to create a new component lock. Then for get, what I'm going to do is I'm going to say lock component locks at type of tComponent. Then I'm going to say action components get type of tComponent. Now you are yelling at me because I need to do a cast right here to tComponent. So what this code will do is it will lock our component to prevent multiple threads from accessing it. And then every single thing within this action will be locked. So again, a pessimistic locking strategy just because of the nature of this application and the fact that it will simplify our code. But no guard against a long-running action. No. See, the way that, for example, that brings up another interesting point. Notice how I'm not doing any error handling in the case of the component not being found. I actually kind of am in a roundabout way. This method, this indexer will throw an exception if the component isn't found, and that's fine. If the component isn't found, we have a bug in our program. It's not an exception that is recoverable. It means we have a bug in our program. If we have a long-running action, that is a bug in our program. That's not something that's recoverable. We should never have long-running actions. Now, what I suppose I could do if I was building a sort of framework type thing that would be distributed to other developers, I could put a warning in place if the action takes X amount of time to execute. But for this particular case, what we'll do is we'll see a performance hit, and we'll be able to figure out, okay, well, that could be because of the long-running action, and then we fix it immediately. It's not something that we would ever want to leave unresolved. So here's our registry. Now, our application and our peer are both going to be needing a registry instance, and they're both going to, and the registry is going to be used to attach these components to it. However, I do not like the idea of passing around objects that inherit from peer base or objects that inherit from application based. So what I'm going to do is I'm going to hide the peer and the application classes behind two interfaces. What I mean by that, let me go ahead and jump into my abstract namespace and add an iApplication interface, which is going to have a registry. It's also going to, then I'm also going to create a iNetworked session, which also has a registry. And then my application is going to have an IEnumerable of iNetwork sessions called sessions. Now you might be wondering, why am I not calling these iSessions? The reason I'm not calling these iSession is because that will conflict with the inhibernate interface iSession, and the code will just be a mess and the world will end. So I added the word network just to resolve that potential name conflict. So now we have our iNetwork session and our iApplication. To hide our application and our iNetwork session behind these interfaces, all I have to do is go into my application and say that this application implements iApplication. Now by doing that, it will require that I implement my registry and my sessions. Okay, everybody with me so far? My registry, my sessions. Now my registry is going to be instantiated in my application. Now my sessions is basically going to supersede my peers property. So what I'm going to do is I'm going to delete peers. Then I'm going to change my sessions to simply return my underscore peers. Now for now, this will be uncompilable because my peer class doesn't implement iNetwork session yet. But once it does, this code will work. So now I've done that, I'm going to jump over to Rune peer and have him implement iNetwork session. And to implement that, that requires that I implement the registry property. And then I'm going to simply instantiate my registry inside of my Rune peers constructor. Now if we jump back over to application, we should see that this code now compiles because iRune peer implements iNetwork session now. And IEnumerable, I don't believe this code would work in any version of .NET before, or any version of C# before 4, if I'm not mistaken, because of generic covariance. So inside of the Rune peer and our application, we both now implement these interfaces that we can use to abstract away the photonness of our framework. But we now need to pass in our iApplication and our iNetwork session into our command handlers, so our command handlers can appropriately work with them. What I'm going to do here is my register handler and my login handler are both going to take iApplication as constructor parameters. So my login handler will also take in an iApplication. These are parameters that would typically be injected by an IOC container, but for now they're not being injected. However, I'm going to have these be listed as dependencies of these command handlers. The final thing I do before I go ahead and give everybody a chance to catch up and ask questions is my handle method. Now my handle method is right here inside. What are you complaining about? Only implementations of method handle are used. Oh, right, derp. Well, of course. I'm going to ignore that. So what I'm going to do is my handle method is going to take in an iNetwork session. So every single command handler, when their handle method gets invoked, is going to get a reference to the session that is basically invoking it. So that's how each handler will be able to do things like authorization, for example. So now, by doing that, I'm going to have a few compiler errors. First of all, my two handlers no longer will compile because I changed the handler or the handle definition. So let me go ahead and fix that. iNetwork session. And then let me do that again one more time in the register handler. iNetwork session. So that's all good. And then let me jump into my Rune peer, which is going to have a couple errors in it, because if you guys recall, I changed the way that my my handle method and my constructor worked. Now keep in mind, this code is going away eventually and going to be replaced with something that doesn't, well, suck. So to fulfill these two constructor parameters, I'm going to pass in the reference to the application into the constructors, and then I'm going to pass in a reference to itself into the handle methods. So that's about it as far as the refactoring. We're pretty much ready to start writing new code now. I'm going to go ahead and pause the video and give everybody a chance to ask questions, because I know I did sling a bunch of code around kind of quickly, because, well, that's the nature of this particular class. But let me go ahead and pause. And we're back. So now let's go ahead and start working with our components. What I want to be able to do is I want to be able to attach a auth component to the peers that are logged in. So let's go ahead and write our auth component. I'm going to, I don't know how I want to do this. Let's just see what this looks like. I'm going to go ahead and write a new namespace called components, because everybody knows I love namespaces. And then I'm going to write an auth component. Now the auth component is going to have a constructor that takes in a uint ID, string username, string email, and that's all I care about. And these are just going to be properties. Now every single rune or every single peer that's logged in will get one of these auth components, and that's how other handlers will know if those peers are logged in or not. So what I'm going to do now is I'm going to jump into my login handler, and I'm going to attach an auth component to the peer when we successfully log in. So to do that, I do session.registry.set new auth component, passing in user.id, user.username, user.email. So, because I would consider a user logged in after registration, I'm going to do the same thing in my register handler. I'm going to say, what did I call this guy? Session dot registry dot set new auth component, passing in user.id, user.username, user.email. So now we've effectively marked both our component or our sessions as logged in the case that we either register or log it in. Now, the next thing we need to do is we need a lobby component, because that's what I said we were going to be working on today. We want the concept of a lobby, and we want the concept of being able to join a lobby. So to do that, I'm going to create a lobby component. This guy's going to be a little bit interesting. He's not just going to contain data that's attached to an application. He's also going to contain additional functionality that's going to be attached to the application. A lobby needs to know let's do a hash set. Why not? Let's do a hash set of iNetwork sessions. So a lobby needs to know who else is in the lobby. And so we need to be able to add a session, and we need to be able to remove a session. Let's rename these methods. I don't like these method names. Let's do join and leave. So what's join going to do? Well, join is going to make sure that he's not already joined in the lobby, and if he is, we want to be able to, well, throw an exception indicating that that's a problem. So what I'm going to do is, in order to handle errors inside of components, keep in mind the components do not have a command context to work with. If you recall, the command context is what's used to set responses, and it's also used to add operation errors and add property errors. But command context should only really make sense in the context of a command. And wow, that was kind of a funny sentence. So we need a way to be able to have the lobby component throw an operation error so that the handlers know that something went wrong and we need to tell the user about something. So I'm going to add a exception class. I'm going to call operation exception, and it's going to inherit from exception. And this is the exception class that we're going to use to differentiate between a normal bug exception or an operation exception. So now that I have that, what I'm going to do is I'm going to say if not sessions.add session, throw new operation exception. You may only join the lobby once. Now, the hash set collection will return false on the add method invocation if that object is already there. So next on my leave, I'm going to do the same thing. If not sessions.remove session, throw a new operation exception. You were not in the lobby to begin with. And then in that way, we can now handle the joining and the leaving. We will be writing more code in both of these methods, because what we need to do is after we add the session, we need to inform all of the other existing sessions that a new session has been joined. So next what I'm going to do is my login and register are both going to add the session to the lobby. So to do that, what I'm going to have to do is actually instantiate the lobby component and attach it to the application. And I'm going to do that within the applications constructor. So I'm going to say registry.set new lobby component. So now I've effectively attached the lobby component to the application. So for my login handler, after we attach the auth component, what I want to do is I want to say application registry.get, and then I want to get a lobby component, and then I want to say lobby.join session. And I want to wrap this in a try catch, and I want to catch an operation exception. And if I catch an operation exception, I want to do context.raise operation error ex.message. So this will allow me to add a session to the lobby, and if they were already there, it will throw an exception. Also, I want to return after doing that. So now if I jump into my register, I want to basically do the same thing. So I'm just going to go ahead and be lazy and copy and paste this. So there's our code that will make our sessions join the lobbies. So yeah, the next thing that I want to do, the final thing I want to do is I want to make sure, or the final thing I want to do, words are hard. Words are very hard. I want to make sure that only a user can only log in once. Now you could be saying, well, we're adding them to the lobby. The lobby only allows one session to be in the lobby at a time. But that's not the same thing as a user only being logged in once. Because if in the future we want to make it so a user perhaps bypasses the lobby, we still want our code to make sure that only one user of a particular name is logged in. So to do that, what I can do is on my login handler, after I make sure that the user logged in properly, I can go ahead and say if application.sessions.any s goes into s registry. I need another method. I need a try get method, because what I need to do is I want to get the component if it exists. Otherwise, I want to not do anything. So I'm going to jump back into my registry class, and I'm going to add a try get, which is going to be very similar. Now, try get is going to say object lock, that's a keyword, component lock, if not component locks dot try get value, type of t component out component lock, then return. So that means if the component isn't on this registry, go away, or just go away. Otherwise, lock my component lock and do an action on components at type of t component, and then of course I have to cast this into a t component. So now I have my try get method. The next thing that I want to do is I want to write 2 overloads of these methods, or 1 more overload of these methods. And here's why. If I jump into my registry handler, or my login handler, so I can do application.sessions.any registry.tryget, and then I can do auth component, and then auth. What I want to be able to say is auth.id equals user.id. However, this code will not compile. The reason this code will not compile is the tryget method does not return any value. So in order to write this code in a way that it would compile, I would have to go ahead and use a for each loop, and I couldn't take advantage of the any extension method without some really gross hoisting grossness. And yeah, so I want to go ahead and make sure that we have this all able to be as clean as possible. I want this code to be able to compile. And I can make this code compile if I take advantage of the way that the C# language, well, works. So if I jump back into my registry, I'm going to write a new get and a new tryget. The difference with these is they're going to return a result. And they're going to take in, instead of an action, they're going to take in a func. Then they're going to do the exact same thing. The only difference is they're going to return the result of this function that was passed in. And that's the only difference. So I'm going to do the same thing with tryget. Now, the tryget, what that's going to do is it's going to return func if it can find it. Otherwise, it's going to return the default of tResult. So let's say that tryget we were working with a Boolean. This would return false if that didn't work. So now if we jump back into the login handler, we can almost make this work. The only change we have to make is we have to specify that the tryget method is returning a Boolean. And by doing that, we can now run this code and it compiles and it works. So now what I can say is if application sessions if anybody is logged in with the same user, then I can go ahead and say context.raise operation error, you cannot log in more than once, and then return. The final thing that needs to be done is I need to lock this code. This code is not thread safe. The reason it's not thread safe is because it's possible that 2 users will be able to get past this check and get their auth component set if they are fast enough at sending in the commands. So that means we need to lock this. And what I'm going to do is on my login handler, I'm going to say private read-only, private static read-only object auth lock equals new object. So this object is this dummy object is going to be used to synchronize access to logging in. Then what I can do is right here, I can just simply say lock auth lock. And there, I have the code. And go away, Brian's group. So here is our login handler. Hopefully everybody is, yeah, let's go ahead and handle that right now. Let's go ahead and work with disconnects. I'm going to jump into my Rune peer, and every time a client disconnects, the onDisconnect method is invoked. Well, obviously. And then we have our application.destroyPeer. And what I'm going to do here is on application.destroyPeer, I'm going to say peers.remove. That will, this code has already been written, and what this code will do is it will already remove it from the network sessions, but it will not remove it from the lobby. So let's think about how I want to do this. Sorry for the silence. I'm thinking. Let's go ahead and just make this as simple as possible for now. If someone gets cut off without legally logging off, that the disconnect is still invoked. My leave method, I'm going to go ahead and I'm going to say public bool, let's do contains iNetwork session return sessions contain session. Then what I'm going to do, so that's the code for, I just added the contains method to my lobby. Now I'm going to jump back into application. I'm going to say registry get lobby component lobby. Then I'm going to say if lobby contains peer, lobby leave peer. And let's do that before we remove it from the peers. Okay, so this will make sure that we can be destroyed properly. Now, the destruction of peers is going to be an interesting topic once we get into the concept of a game session that's going on. And we'll deal with that, well, later, because we can. So now, in theory, what I should be able to do is I should be able to build this out. Let's go ahead and open up my logs and open up my Photon control panel. Now what we should be able to do is we should be able to make sure that only one user can log in at a time. So let's verify that. Hold on, let's wait for my application to start. And it started. So now what I'm going to do is hit Control B. Sure. What do you build? RuneSlinger exe, replace, yes. I'm going to fire up Explorer, and I'm going to start a rune peer. And then I'm going to log in with Nelson at rebuzz.com with test. And area developed. Is it Nelson 2? Yes. Okay, so that's Nelson 2 logged in. So let's see what happens when I try to log in with Nelson 2 again. We get success. For some reason. So let's figure this out. And if anybody says anything about unit testing, I'm going to slap them. Let's make sure I built. I might have forgotten to build right, so let's try this again. Okay, so the application is indeed restarted. And we logged in. Now let me jump into Unity and try to log in. Blah, 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 blah. Oh, there we go. It works. You cannot log in more than once. Now you guys see how I didn't build the application. I forgot to compile the application, so I was using an old version. So you guys can see, though, how the way that we wrote the code earlier, the kind of frameworky stuff we put together, allows us to do things like later, after the fact, throw in errors such as you may only join the lobby once and all that stuff, and everything gets handled very very awesomely. Awesomely, is that a word? Someone with a thesaurus correct me on this word I just tried to say. But everything just works right. Basically is what I'm saying. I was able to add in a check for whether or not you can log in, and that error now propagates to the client appropriately, and everything is just awesome and wonderful. So I'm going to go ahead and close this client and make sure we can now log in. And guess what? We can. So after closing the other client, we were able to log in. So yeah, we got a lot of actually really good stuff done so far. I'm probably going to go on break just because right now is a good sort of time to do that. The only bit left of the frameworky type code that we need to write today is we need the concept of being able to send an event to our sessions. So for example, what I want to be able to do is in my lobby component, I want to be able to say when we join it, I want to say session dot publish, new joined lobby event, list of current clients, and then I want to be able to say for each var session in sessions session dot publish new session joined event session, something like this. We need to be able to tell the other clients that something happened. And once we get that bit done in our frameworky type code, then we'll be ready to actually create a lobby where people can log in and chat to each other, and they'll have names and stuff. Yes, there is the concept of broadcasting things, but we need to abstract it a little bit so that it'll work with our iNetwork session abstraction. And I'm going to do something similar to the commands, where we'll be able to make things strongly typed and pretty looking. All right, so I'm going to go ahead and pause the video. And we're back. So yeah, I hope everyone sees like the way that we've been approaching this this project, where we've been sort of writing some code and seeing what we need in the base code, then writing that base code, and then using that base code to write more code, and so on and so on. So again, this is very organic, and right now we're in a situation where we need a way to inform other sessions that something has happened. Now, fortunately, there is a way to do that within Photon, and those are called events. So if I jump into RunePeer, it doesn't matter where I am in RunePeer, I just want to show you guys the IntelliSense here. There's a send event method, and a send event method takes in an event data and a send parameters. The event data thing is very similar to our operation request in that it takes an event code as well as one of our untyped byte object dictionaries. So what we're going to do is we're going to basically write a wrapper around send event that will tell the client that something has happened. We're going to be using this for things like other people join the lobby, or maybe a game event happened, like a rune was placed or something like that. So to do that, I'm going to jump all the way back into my base, and I'm going to write an iEvent. The iEvent interface is very similar to the iCommand interface in that I'm just using it as sort of a marker. I'm saying, okay, well, let's mark an object, or a class rather, as an event. So now that we have our iEvent, let's get an example of what an event is. So then what I'm going to do is I'm going to write an events namespace inside my base. The reason that events have to be inside the base project is they have to be available for both the client and the server. So what's an example of an event? Well, let's do a join lobby event. Now, the join lobby event is going to implement iEvent, and it's going to have data in it that tells the client that just joined the lobby what other clients are in the lobby. So what we need to do is I need to write an IEnumerable of something. And what's that something going to be? That something is going to be a session. So what I'm going to do is I'm going to write a nested class inside of join lobby event. And I might change this later. This is, again, I'm writing this stuff off the top of my head. I'm just writing the bare minimum that I have to do for now. And I might move this around later. But for right now, I'm going to represent this as an internal object to, or internal class, a nested class rather, to the join lobby event. And what's going to be is it's going to be lobby session. And a lobby session is going to have a uint ID and a string username. Notice how I do not have the email set here. And the reason I don't have the email set here is because the only reason I have this class is to inform other client, or to inform us that other people are in the lobby. And because of that, I don't want to send any sensitive information. All I need to send is the ID and the username. That way, by sending the ID and the username to the client that just joined the lobby, for now on, all we have to do is send the ID to the client when another person has done something, and then the client will have a dictionary that associates the ID with a particular username, and that will be used for display purposes. So then I'm going to have the join lobby event take in an IEnumerable of lobby session called sessions. And I'm going to move this guy down because I like my nested classes to be at the top of the class. So here's my join lobby event. Then I'm going to, let's see. Actually, I'm going to take this lobby session and I'm going to move it. I'm going to move lobby session into a value objects. I'm going to create a lobby session. And there we go. And there. The reason I did that is because now I'm going to write, so this is the event that's sent to a person who just joins the lobby so that he's aware of who else is in the lobby. But now we need an event to send everybody else in the lobby that a person just joined. So then I'm going to write another event called session joined lobby event. Oh, these are horrible names, but I can't think right now. There we go. So now we have a session join lobby event. This event will be fired to everybody who is already in the lobby to make them aware of a new user being in the lobby. Then finally, I'm going to have one more event called session left lobby event of type IEvent. And he's just going to be a uint session ID. Or session ID or user ID? User ID, because we don't have session IDs. So this tells people that a session has left the lobby. So now we have our 3 events, and that's all we need in order to construct a list on the client side as to who's logged in. Now we need a way for our lobby component to publish to our things that something happened. So to do that, I'm going to jump into my iNetwork session abstraction, and I'm going to write a void publish method that takes in an IEvent, and I'm going to call it an event. The reason I have the @ symbol in front of it is, of course, because event is a keyword in C#. So now that I have the publish method, I can finish my lobby component implementation without actually having to write a my client quite yet. So let's do that. I'm going to rewrite this. Instead of adding the session right here, I'm going to say if sessions contains session, then throw this exception. Then session.publish, and I'm going to say lobby, what am I going to say? I'm going to say join lobby event. Then I'm going to pass in sessions.select tt.registry.get auth component, comma, lobby session. Auth goes into new lobby session, auth.id, auth.username. So what does this code do? This code just goes ahead and publishes a join lobby event to the user who just joined the lobby, and it converts all of the existing sessions into lobby session objects by passing in the auth.id and the auth.username. Then I'm going to loop through every single session that's already in the lobby, and I'm going to, first of all, I'm going to write a var lobby session equals new lobby session, or how about basically just session.registry.get auth component, comma, lobby session, auth goes into new lobby session, auth.id, auth.username, and then I'm going to do session join lobby event, lobby session. Then at the end of this, I'm going to say sessions.add session. So again, very, very straightforward code. And because of the way we wrote the registry and because of the way we wrote our abstractions, we do not need to worry about any sort of race conditions because I'm using a very pessimistic locking strategy. Next up, I have my leave. What's my leave going to do? Well, it's going to check to see if we can remove the session, and then I'm going to say for each var existing session in sessions. First, I'm going to extract the user ID from the session. So I'm going to say user ID equals session.registry.get auth component, comma, uint. And then I'm going to do auth goes into auth.id. That extracts the user ID from the session. And then I'm going to say for each of our existing session and sessions, existing session.publish, new session left lobby event, user ID. So all this code does is it informs everybody else that the user has left the thing. So now that I have that code written, the last thing I need to do at this point, the server is pretty much done as far as the application code of the server, but I still need to write the publish method. And the publish method goes on the Rune peer. So let's go ahead and write the publish method. The publish method is simply going to invoke the send event, and it's going to pass in a serialized event into the peer. So let's go ahead and do that. Remember how I wrote these enumerations up here? The Rune operation code parameter, response parameter. Well, I need two more enumerations. I need a Rune Rune event code, and this one's going to be send event. And then I need a Rune event code parameter, and then this is going to be type. And then let's do event type and event bytes. So now we have our Rune event code and our Rune event code parameters, and those are going to be used to just for our frameworky type code to tell the client that an event has been received. So inside of Rune peer, I can now write this code. I can say send event. The event data is going to be a Actually, hold on. Let me make both these enumerations use a byte as a backing type. There we go. Then I'm going to say cast a byte Rune event code dot send event. Then it's going to pass in a new dictionary of byte and object. The send parameters, I'm going to pass in a new send parameters, and the send parameters is going to be unreliable equals false. Then finally, what I'm going to do is I'm going to fill in this dictionary that I passed in. Let me go ahead and make this code a little bit cleaner here, because it's kind of getting gnarly. It's getting very gnarly. I hate. There we go. That looks better. So basically this send event is the opposite, or the okay, can you guys see the Unity project right now? in Visual Studio? Okay, good. I just wanted to make sure I didn't do that stupid hiding thing again. The method I'm about to write is the opposite of this. No. It's the opposite of, wow, dispatch internal. So that's basically what I'm doing. I'm doing what the client does when it sends a command. I'm doing the opposite when sending an event, or the same thing but in the other direction. So the first thing I need to pass in is the rune event code parameter dot event type. Now the type of the event is going to be event dot get type dot assembly qualified name. So that tells the client what event was actually fired. Then I need to send in the actual bytes. So rune event code parameter dot event bytes. Then I need to pass in serialized bison event. So by doing this, I am now sending an event to the client, and I'm serializing my event into Bison. So that's about it for the server, really. I'm going to go ahead and build. And the server is pretty much done. Now we just need the receiving code on the client. And the receiving code is basically going to be what this code does, but just in the opposite direction. We need to receive an event from the server. We need to find out what event type it is, and then we need to deserialize it using these event bytes. Then we need to tell the client that something happened. So I want to make this code as simple as possible for now, just because we're getting short on time. So let's look at the code. OnEvent is a method. So remember, I'm on the class right now, the network manager, in my client code. So I'm in Unity right now on the opposite side. And I'm on the class that implements iPhoton Peer Listener. When implementing iPhoton Peer Listener, you have to implement a method called onEvent. This method is invoked when Photon receives an event from the server. And the event data contains my code and my parameters. So what I can do here is I can say if event data code does not equal byte rune event code dot send event, then throw new invalid operation exception unknown event received from the server. Then I can go ahead and say var type equals string event data parameters byte at rune event code parameter dot event type. I'm going to say var bytes equals byte array event data parameters byte rune event code parameter dot event bytes. So I've extracted the type of the event and the bytes of the event. And I can use these 2 bits of information to deserialize Bison. So right now I have a deserialized Bison method that requires that I pass in a strongly typed generic parameter. I'm going to write another deserialized Bison method that just can deserialize anything. So I'm going to write another deserialized Bison method that takes in bytes, and then it's also going to take in bool type, and then bool is array equals false, and then I'm going to say var using var ms equals new memory stream of bytes, and then I'm going to say return JSON serializer dot deserialize. Then I'm going to pass in a new Bison reader, passing in my memory stream and is array, and then datetime local. And then I'm going to pass in type. So what this deserialized Bison method lets me do is it lets me deserialize anything at runtime, as opposed to this deserialized Bison method that expects a generic parameter. So I'm going to use this deserialized Bison to say var event equals at iEvent, or iEvent deserialized Bison bytes type. And what are you complaining about? Oh, because the type is a string, I need to turn the type into a type. So I do type.getType and then type. Type. Now we have a event object. So at this point, we now have an actual event object that we can send to the rest of our code. So to do that, what I need to do is I need to tell the game manager that event was received. There's a lot of really cool ways that I can do event wiring, but for now, what I'm going to do is I'm going to try to keep things as simple as possible, just for now. So inside of my game manager, I'm going to turn game manager into a singleton, and then I'm going to send the event to the game manager, and that's all I'm going to do for now. We'll make it a little bit nicer at a later time. So to turn game manager into a singleton, I just have to say public static game manager instance get private set, and then on start I say instance equals this, but I say if instance does not equal null, throw new invalid operation exception, cannot create more than one game manager. Then what I'm going to do is inside my network manager, I'm going to say game manager.instance.publish event. And then I'm going to have ReSharper generate the method stub for me. And then I'm good. So now I have a publish. So what events do I need to handle? Well, there are 3 events that I need to handle. I need to handle my join lobby event, which gives me a list of everybody who's already in the lobby. My session joined lobby event, which happens when another person joins the lobby, and my session left lobby event. What I'm going to do is, in the interest of keeping things simple, I'm just going to create a list of strings that will allow me to display something to the user. So I'm going to say private list of string. I'm going to call this messages, and then I'm going to instantiate it here. And remember, this is exactly what we did when we started this with the first chat client. And what I'm going to do is, when my state says that we're logged in, I want to have messages display on the GUI. So if we're on logged in, then I'm going to say, what am I going to do? I'm going to do something. GUI layout dot begin scroll view, and then I'm not going to worry about a scroll view, really. Say GUI layout dot begin vertical. I'm already in a vertical, so I can just say for each var message in messages GUI layout dot label message. That's all I gotta do. So this will display every single message that's in that list. Now I have 3 events to handle so far. So what I'm going to do is I'm going to say if event is lobby joined event or join lobby event, then say var join lobby equals join lobby event. I'm going to say for each var session in join lobby event dot sessions messages dot add blah 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 is in the lobby. Session dot username, session dot ID. I'm going to do this. Lobby event. This, again, I don't like the way that this code is written at the moment, but it will be fixed. So var join lobby event, and then we need a lobby joined event equals event as lobby, or session join lobby event, sure, and then a var lobby left event equals event as session left lobby event. Then I can say else if lobby joined event does not equal null, then I say messages.add join lobby event session.id, or join lobby event sessions.id. There we go. So if another person joined the lobby, tell them that they've entered the lobby. Finally, if somebody left the lobby, then say messages.add left the lobby. Lobby left event.userID. Okay, so we now have our code on our client. I say I don't like this code. Can you give a brief overview about how you might improve it in the future? The way I would improve it in the future is making it so we don't have to sit here and check manually for every type of event. I would write a class responsible for event handling for every type of event, very similar to how we are handling our command handlers. But anyway, so now we have this code written. Things should just work, but they're probably not going to because that's the nature of code. Code hates me. Okay, so I'm going to go ahead and build and play, and then log in with Nelson2 at 3dbuzz.com, test, sending, and then we're in the lobby now. So let's go ahead. I'm going to register another one. I'm going to say stuff and things, Nelson4 at 3dbuzz.com, test, register. And how's that, guys? Come on. That's pretty sexy, isn't it? Then let's go ahead and close this out and see what happens. 3 left the lobby. So yeah, that's our code. The last thing I want to do is I want to actually write one more event and one more command. And let's see how that turns out. So the hope is now that I have pretty much all that groundwork laid, I should be able to write a new command and a new event very easily for sending and receiving chat messages. So let's do that. I'm going to create a send message or send lobby message command. He's going to implement iCommand, and he's going to take in a string message. Then I'm going to write a message or lobby message sent event. He is going to implement iEvent, and he is going to take in a uint user ID and a string message. So this event will tell everybody else who's in the lobby that a message was indeed sent. Then I now need to write my command handler. What did I call that command again? Send lobby message command. So I need to write a command handler for send lobby message handler. He will implement iCommand handler of type send lobby message command. He is going to take in an iApplication as a constructor parameter, and then in his handle is going to be application registry get lobby component lobby send message, passing in the session that sent the message as well as the command.message. So he's going to do that. And then in my lobby component, I'm going to say if not sessions contains session, then throw new invalid operation exception, cannot send a lobby message if you are not in the lobby. Then I'm going to say for each of our existing session in sessions dot blah 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 where t dot does not equal session. I'm going to say var user ID equals session registry get auth component of uint auth user or ID. Then I'm going to say existing session dot publish new lobby message sent event user ID message. Okay, so how's everyone feeling about the code that we just wrote? And it wasn't a whole lot of code. All we had to do was create our command, our event, our command handler, which is one line of code, really, if you think about it. And then inside of our lobby component, we actually put the actual code in for that. Well, we'll get to the client in a second. We have one more thing to do on the server, and I want to stress that the only reason we have to do this on the server is because I haven't yet cleaned up this code yet. So let's go ahead and write the last bit of code inside of here. Again, this isn't a step that we would need once we get the code nice and sexy looking. So yeah, so again, this is just nasty code that should be handled through reflection, not through manual code writing. And that's it for the server. Now we need to do the client. And what do we need to do for the client? Well, we need two things. We need an event handler that's going to be inside of here that will handle code when the execute code when we receive a message, and then we also need one more way to dispatch a command. So what I'm going to do is I'm going to add a delete that. Well, no, I won't. I'll go ahead and say private string message. This message string is going to contain the message as we type it. Then inside of our game manager logged in state, I'm going to say GUI layout dot begin vertical, and then GUI layout dot end vertical. Then I'm going to say message equals GUI layout dot text box or text field message. Then I'm going to say if GUI layout dot button send, then send message or send lobby message, because there already is a send message thing in Unity. So send lobby message is simply going to send a command to the server, and all it needs to do is say network manager dot instance dot dispatch new send lobby message command passing in message. Or message, not messages. And then I also need response equals empty lambda. We're not going to do anything with the response of the send lobby command. So that's it. Now this code should work, but it probably won't, because typically code never works. Oh, derp. I sent the I wrote the command sender bit that sends the command when the button's pressed, but I didn't actually write the code that handles when a message is sent in. So give me a sec. Message sent event equals event as message sent event, and then I'm going to say else if message sent event does not equal null, messages add said blah. There we go. Okay, it's still probably not going to work, but let's see what happens. Let's log in. Nelson2 at 3dbuzz.com. Test. Login. And then we have this, so we can send messages, but it doesn't currently display on the user who sent the message. That's by design. It shouldn't be. I'll fix it later, whatever. Nelson4 at 3dbuzz.com. Test. So we have that. And hey, look at that. It actually works. Okay, so that's really about it. Very simple code once you remove all of the bits all the frameworky type stuff. And that's really the goal of writing code like this. So at the end of the day, our login stuff and our register stuff and our lobby stuff is actually just very straightforward, simple C# code. But there are some important facilities that are provided by the framework that's been written so far, such as our validation, which is very important. We also have our synchronization, which is incredibly important. And on top of that, we have our ability to create components that can talk to other sessions in a way that's thread safe and in a way that will allow us to very simply send new types of messages to the user. So I think that's about it. I'm going to go ahead and pause the video and see if anybody has any questions, and then I guess then we're done. Okay, so we're back. Is there any reason you just didn't use the existing commanding structure for events? Have the server send a command as it receives an event? Well, the reason I needed to do that is because the way Photon works. It's not like I could send an op custom back to a client. Photon's own terminology is you have an operation, which is an operation is something the client sends the server, and then you have an event, which is something the server sends the client. And I also wanted the terminology to be very different and distinct. I wanted the thing that the client sends the server should be called a command, because that's what we're doing. We're sending a command. But the thing that the client or the server sends a client should be an event, because the server is making the client aware of some sort of change in state. So I think the language is very important because it also allows us to separate out our command and event DTOs in a meaningful way. Because these two namespaces will grow as our application grows. Because at this point, the way that we extend our application framework and add in things like actual game logic is going to be doing exactly what we've been doing. It's going to be adding commands and adding events, adding components, and then adding handlers. And then adding event handlers on the client. And through those different things, we will have a very standardized format of extending the application as we see fit. So again, the goal is to sort of identify an abstraction and then use that abstraction to make our code base consistent. And the abstraction that I chose was the command and event abstraction, which allows us to make our code very consistent in that we'll be able to very easily spot code. So for example, we'll have a join game command and a place rune command and so on. If this were an MMO, we would have a move command or a destroy item command. And we would just be able to build off what we have right now. And like I said, as the application matures, our command handlers and our components will grow. As far as the name, people aren't liking the publish that I have on the client. I guess that's just a bit of preference. I mean, the way that I see it is a publish from a server to a client means that the server is sending the client something. The publish within the client means that the client is internally publishing something to itself, if that sort of makes sense. I don't know. It's complicated. Right, to the UI. We're publishing from the Photon peer object to the user interface. And yeah, I can't wait to get this code cleaned up. But the problem is to clean this code up is actually going to require some work. And the reason it is because during the course of a application, like a game, we will be attaching and detaching event handlers from my network manager. So as we detach and reattach different event handlers, that makes the code a little bit more complex than what I wanted to cover today. Right. Different. So when you're in a game, you'll want to be able to handle all the game events, but when you're in the lobby, you'll want to handle all the lobby events, and you'll want to have those things separate from each other. Because if we just continued with this code would get very, very, very big and very ugly. However, this bit right here, which is very similar actually to the client code, this code right here is going to be a bit easier to clean up just because what commands the server handles does not change during the course of the server's runtime, whereas what events the client handles does change, if that makes sense. But we'll clean this up to be automatic soon when we introduce IOC. Okay, if that's it, then I guess it's time to go ahead and tell all the future people goodbye. I don't see any more questions. So, yeah, hopefully people learn things and stuff. So, goodbye, future people.